what we are saying is at C, we know that x is equal to 0. How do I know that x is equal to 0 at C? How do I know that at C x is equal to 0? Because C is on the y-axis, right? And the equation of the y-axis is x is equal to 0. So at C, x is equal to 0. Then I can just take that thing and sub into the function y equals 9 minus x squared. So if you do that, you will get y is equal to 9 minus 0 squared, which is 9. Okay, guys, so that is why point C is 0, 9. So yeah, your methods are the same. You can make use of the fact that C is the turning point, and the coordinates of the turning point are always given for you guys as 0q. But looking at the function of f, q is 9. And you start from there. Okay, well done. It says find the length AB. Do you take a ruler and measure? No. So how do we find the length AB? First, you need to know where A is and where B is, right? Who can tell me where they are? They are on the x-axis. We can turn that into a math statement. A and B are on the x-axis. You won't write that. What are you going to write? You're going to say at A and B, what are you going to say? You said A and B are on the x-axis. Therefore, at A and B, x is equal to 0 or y is equal to 0? It's y which is equal to 0, right? Okay, good. So at A and B, y is equal to 0, we know that, right? But also, where are these 2 points? Where is A and where is B? They are on the x-axis, but that is not all. Where else are they? Yes.
A is smaller than 0 and B is
Sorry?
A is negative and B is positive.
Yeah, where are they? where are they? Can you see they're on the x-axis?
Yes.
Where else are they? They are on the function. They are on the function f, right? Those points lie on f of x. They are on the graph of f of x. So at that point, we know that y is equal to 0, but we also know that y is equal to 9 minus x squared. Remember, f of x means y. So this is the thinking that goes into this. Because they're on the x-axis, y is equal to 0. Because they are on the quadratic function, it means y is equal to 9 minus x squared. Then we need to solve these two equations simultaneously. If y is 0, then what is x? We just substitute, right? Y is 0, so what is x? I'll move x. I know we can use difference of 2 squares. Is that what you want to use? Or can I move negative x squared to the left-hand side and get this x squared is equal to 9? And then to get x, I need to take the square root of 9, but then remember plus or minus. So x is equal to plus or minus 3, right? So give me the coordinates. We don't really need the coordinates of A, but you can give me the coordinates of A now. Should be negative 3 and 0. What about the coordinates of B? 3 and 0. Okay, so therefore, what is the length of AB equal to? So the length of AB will be 6. You can take the value of x at B and subtract the value of x at A, and that will give us 6 units. You can just leave it as 6, but if you need some units, it is not centimeters, it is 6 units. Okay. I'll be very happy to see you answering these questions like this. Why you are writing this kind of statement here is obviously you're communicating with whoever is reading your work, and you are also helping yourself think through the problem, because you need to process this thing properly. If you don't understand these properties, you may not be able to find X and Y. But do you think there is another way of telling what point A is? Without, if you don't want to use this method, can we find A another way? Yes.
The function of f and g.
Okay. So you mean the intersection? Okay. So it's the intersection. Point A, this is just another way. At point A, the two functions actually have the same values. So at A, f of x is equal to g of x, right? So if you are looking for A, you can solve this equation. F of x means 9 minus x squared, and gx means 2x plus 6. You may not like it, but I think later on you will need it anyway, because we need to work out d. Did you see that? We need to work out d. So I'm saying O, but can we just take advantage, guys, and answer part D straight away? Is it part D or part C? It's C. Okay. So this here will give us point A. So if you did not want to get A like this, then you can get A like that. But question C says determine the coordinates of D. But if you look at A and you look at D, these 2 points are at the intersection of the two graphs. So it's at A and at D really. But we know A already. Okay, so that is the equation that you form. Rearrange it and organize it into a nice quadratic equation. You end up with x squared plus 2x minus 3. I agree with you. Collect your like terms. Remember, for quadratic equations, we really want one side to be equal to 0, so that we can factorize and then make use of the fact that if numbers are multiplied by each other to get 0, then either one of them should be 0 or both. Okay, so that is where you are. Then you factorize this. You still remember how to factorize? So who can give me the answer? Factorize? Yeah.
X plus 3 in one bracket and x minus 1 in the other.
X plus 3 in one bracket and x minus
1.
1 in the other bracket. Okay, yes, that is correct. This is the right time for you to learn how to factorize. I've seen people struggling in metric, always using the quadratic formula when they can factorize. And it is because in grade 10, people were running away from factorization. This is a very important tool, so we shall be using it. So if x plus 3 multiplied by x minus 1 is equal to 0, then tell me what x is. I'm not interested in the steps in between. You can show me those steps. I won't give you marks for those. But what I want now, after factorizing, tell me the answer. So what is x equal to? Minus 3 or? Okay, minus 3 or 1. But we know that we are looking for D in part C. Okay? So we know that at D, x is equal to 1. We need to find 1. How do we find 1? Because we are looking for the coordinates.
Can't we substitute?
Yes, substitute. Where do you want us to substitute?
With g.
You want to substitute in G. And where there is x, what do you put in G?
1.
You put 1. Can we substitute in F?
No. Oh, why not?
Can we substitute in X? Yes, we can substitute in F because D is on both of them, right? So we can substitute in either, and obviously, why substitute in F when you can substitute in G? Because I think G is just linear and simpler. than F, but maybe not that tough really. So let's substitute in G. And so we get an answer of 8. Or if you want substitute in F, you will still get 8. And then please write your coordinates because they are asking for coordinates. So your final answer should be 1 and 8, given properly in coordinate form. D says determine the length of PQ given that OR is equal to 1. So we need to know the length PQ given that the distance from O to R is 1. Okay. Any thoughts? Any thoughts?
I'm seeing where's R?
Origin.
O is always the origin, okay? Okay. Your thoughts, please? Yes.
So my thoughts are, can I say how I solved it?
Yeah, just one little thing at a time.
Okay, since the length of OR is 1 unit, that means that R is at -1, 0.
That is correct. They are giving us the length OR. That is just a clever way of telling us what the coordinates of R are. Right, so it is 1 unit from the origin to there. So for that to be 1 unit, clearly we are moving to the left. It means the coordinates of R should be -1 and 0. So we know that R is -1 and 0. Okay, and therefore, because of that, what else do we know? So we are saying the coordinates of R are -1 and 0. Anything else that we know? Yeah, continue.
We know the x coordinates of Q and P, so we substitute those into the equation.
Right, so now we know the x coordinates of P and Q. So you could say at P and Q, we know what x is, right? What is x at P and Q? It is also -1. And we know because this line is perpendicular to the x-axis. So this is a vertical line, which means these points form a vertical line if you join them. All right, guys, so we know that at P, x is -1, and at Q, x is -1, and we are looking for this distance. Do you see that that distance is a vertical distance? And for us to get this vertical distance, we need to know what y is at P, and we need to know what y is at Q, correct? You can write that any way you like, but do you understand if I say, well, I'm trying to develop something here? Do you understand if I say the distance or the length of PQ will be equal to f of x minus g of x? I'm not trying to confuse you. Do you understand what I mean by that? This means the same thing as the y value at P, correct? F of x is the y value at P, subtract the y value at Q. That is just another way of explaining it. But for me to get the y value at P, what do? We substitute x equal to -1 into which equation? Into 9 minus. All right, okay. So yeah, you can complete this, I'm sure. The y value at P will be 9 subtract -1 all squared. I think this is equal to 8. Okay, that's 8. Then the y value at Q is equal to 2 into -1 plus 6. Is it 4? That is 4. Therefore, the distance PQ should be 8 minus 4, which is equal to 4 units. Okay. Right. Well done.